Well, can you see that now? You don't see anything. All right, let me try to reshare. Okay, screen share. Cancel. Screen share. Share. There?
Yeah.
Cool. All right, so remember we're talking about vectors, which are, you guys are experts on from, well, Greta and Sarah were experts on from physics, right? Absolutely, right? All right, so vectors are just a way of showing magnitude and direction, basically. Yeah, that's basically what they are. So we kind of went over some basics about vectors on Monday. We talked about the component form of a vector. All right, so here's, if you have a vector PQ, right? You can subtract the coordinates basically from each other, and you get basically the x direction and the y direction, and they're written with these little brackets, and we would call that vector v. And if you want to find the magnitude of the size of that vector, you're going to use this formula. So the magnitude has these two lines, looks like double absolute value, right? And the magnitude basically is using the Pythagorean theorem to find the magnitude of the vector. So we talked about that. If your magnitude is 1, it's called a unit vector. Yeah, so that's what's going on with that. We can add two vectors together, which is kind of what we were doing at the end of class. And we can also multiply by a scalar multiple, which is like if you have a vector v and you multiply by 3, it's 3 times the size of that. Okay, so that's kind of what we talked about at the end of class. We didn't quite get through all the examples, so might be good to do a couple of those. So I think where we left off was where do we do? I think we did like 20 through 24, right? I think that's where we left off. So let's just do, I think today's kind of going to be a lot of examples. I mean, not that we don't do a lot of examples, but let's just kind of do, there's lots of different things that you can do with vectors. And so let's just kind of do some of the different things that we can do with a vector. All right, so if I can do this. Okay. So it says in exercises 25 through 30, find u plus v, u minus v, 2u minus 3v, and v plus 4u. So basically they are giving you some vectors and they want you to figure out what they might mean. Okay. So let's look at number 26. And we won't do all these, but number 26, we have vector u is 5, 3, okay? And vector v is -4, 0, okay? And then if we wanted to, for example, do part A and add vector u plus vector v, what would that look like? Okay, so you can do this graphically, right? Or you can do it algebraically. So literally vector u plus vector v means that we're going to add together 5, 3 plus -4, 0. Okay, and so you're going to basically add the x part together. So 5 plus -4 is 1, right? And then 3 plus 0 is 0. So vector u plus v would be 1, 0. All right, so if I had a graph up, let's see, if I had a graph, let me do a really, really quick graph for you. Okay, so I have a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so if I had a graph and I graphed vector u would look like, it would be 5, 3. So vector u would look like this. Okay, and vector v is negative, so this is u. So I'm at basically 5, 3, right? And vector u is at negative 4, 0. Right? This is vector v. If I add them together, remember when we were doing it graphically, you're going to go vector u, you're going to go 5, 3, and then you're going to go vector v, which is this way, right? And I did something wrong. Oh, wait, it doesn't work like that. I apologize. Did I do something wrong? 5, 3, negative 4, 0, and it ends up, oh, no, no, no. I added wrong up here. I'm like, hold on a second, that should work. That should be a 3 right there. If you add 3 and 0 together, it should be a 3. All right, so if I add together vector v, which this is inappropriately labeled now, this is u, and the yellow one is v, right? If I add them together, the two vectors combined come to a point which is at 1, 3, right? But it's not a coordinate like 1, 3, it's a vector at 1, 3. So it feels like you're just plotting points, but the difference is you have this direction that goes with it. So if I just asked you to plot the point 5, 3, you would just plop a point down at 5, 3, right? But because it's a vector, it's going to start at 0, 0, it's going to go out to 5, 3, then it's going to go back 4 units, and you're going to end up here. So this black vector right here would be u plus v. Okay, does that kind of make sense when you see it all put together?
Yeah.
Okay. So cool. All right, so a couple other things. If we did part C of this, so part C has, let me scroll back up. If you wanted to do part C, it would be 2 times u minus 3 times v. Okay, so then you're actually going to multiply by a scalar. So u is 5, 3 minus 3 times negative 4, 0. So you're going to go ahead and multiply by the scalar first. So you would get 10, 6 minus negative 12, 0. Sorry, I keep putting that there. All right, and then you're just going to go ahead and, well, for this case, you're going to subtract them, right? So it would be 10 minus a negative 12. So it would be 22, and 6 minus 0 is 6. So your new vector would be at 22, 6 if you kind of graph that all out, and you would get the same thing. Okay. All right, so I think that makes sense once you see it. It's like, oh, okay, that makes sense. Hopefully that makes sense. If you were doing your homework and you're going along and you're like, okay, I'm good. And then all of a sudden you get to 26, 28, no problem. You get to 30 and you're like, wait a second. What happened here? Mrs. Ross didn't tell me about this. So number 30 says that u, I always do that, u equals 2I minus j, and v equals negative I plus j. You're like, whoa, 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 what happened here? I had some nice numbers going on, and you just basically made them that crazy. So I and J are called a linear combination, and it's just another way of writing vectors. So Greta, have you done this in physics yet or not? Okay, you don't think so. All right, so basically, it's just another way of rewriting what we had. So you can think of this as the I is kind of like your X um, in vector land, and your J is kind of like your Y in vector land. Okay, so all this basically means is that this is 2, -1. All right, and all that this means is that this is -1, +1. So the I basically represents your X part of your vector, and the J represents your Y part of your vector. Okay, the thing with this is that it makes it easy if you're this is one format for how you can write your vectors. This is another format. It kind of simplifies it for you though, because if you do I or U plus V, right? You could just say that U is 2I minus J plus -I plus J, right? And then you're going to add basically your variables together. So 2I minus I is I, and minus J plus J is nothing. So this one actually ends up being, when you add them together, you could say that U plus V equals I, or if you kind of translate that back, that means that there is a 1 for the X part and a 0 for the Y part. So if you see I and J, not a big deal, just kind of a different way of working with the numbers. So can you see how those translate? If I wanted to do, for example, part D of number 30. So part D says, what is V plus 4 times U? Okay, so V is -I plus J plus 4 times U, which is 2I minus J. Okay, so now I need to distribute my 4, and I get -I plus J plus 8I minus 4J. Okay, I add them together, I get 7I minus 3J, which is equivalent to, if I wanted to write it in the other format, it's equivalent to 7, -3. So the I and the J basically just indicate, are you talking X or Y? Okay, makes sense? Not too
Yeah.
bad? All right, cool. All right, really quickly, when you get to problem number 32 or 34. Cool. This is just a quick little thing. Let me just show you what you would do. So it says in exercises 31 through 34, use the figure and write the vector in terms of the other two vectors. Okay, so look at this little picture here that I kind of drew a line through already. But what it looks like is if I add together U plus V, I get W. That's kind of what the basic picture shows me, right? Always do that. U plus V equals W, right? So if I wanted you, I think number 31 says, tell me what W is. So number 31 tells me what W is. So W equals U plus V, right? If I wanted to know what V was in terms of the other two vectors, I would just use the same equation and say that for number 32, V equals W minus U, right? If I subtract U from both sides, I get what V equals. That makes sense? Um, so that's how you would solve that equation. It's kind of just a quick, easy one. All right, let's do some more things. Yay. Like I said, we kind of introduced the concept, so now it's just showing you some different ways that plays out. All right, so let's talk about this. In these exercises, find a unit vector in the direction of the given vector. Okay. Find a unit vector in the direction of the given vector. So remember, a unit vector has a magnitude of 1. So basically, this unit vector, you know it's going to have a magnitude of 1. It's just going to go in the same direction as your initial vector. Okay. There is, in your notes, if I can find back there, a little thing about how to find a unit vector. So let's go ahead and print screen that. Make this bigger so we have our notes here. And paste. Okay, it says, in many applications of vectors, it is useful to find a unit vector that has the same direction as a given non-zero vector v. To do this, you can divide v by its length and obtain the unit vector u equals the vector divided by the magnitude of the vector, which is equal to 1 over the vector. Okay, so let's talk about what this means. All right, so number 38. Okay, number 38, we have a vector. Number 38, we have a vector. It is a vector that is at 3, -4. 1, 2, 3, 1, 2, 3, 4. So it's at 3, -4. It goes like this, right? We'll call that vector v. This is at 3, -4. I always want to end it like that. It's a vector. It's different than a point, right? Okay. I want to find a unit vector that goes in the same direction but only has a length of 1. Okay, so I know that to find a unit vector, I take my vector and I divide it by the magnitude. All right, so if I want to find the magnitude of vector v, in number 38 right here, remember, it's basically you're doing the Pythagorean theorem, right? These vectors, though, happen to be at an origin of 0. So that's nice and easy, right? So it's going to be 3 minus 0 squared plus -4 minus 0 squared, all square root. Okay, so 3 squared plus basically -4 squared. You might know what this is. When you do the math, this actually gives you 5. So the magnitude of vector v is 5. So if you drew this on a graph and measured it out, that would be 5 units long. Okay, to find the unit vector, what I'm going to do, so my unit vector is going to be called u. To find my unit vector, I'm going to take my vector, which is 3, -4, and I'm going to divide by the magnitude. Okay, so what this means is I'm going to have a vector that is at 3/5 and -4/5. And that's going to be my unit vector. So if I drew this on here, something at 3/5, 4/5 is going to be about that long. That little green thing is my unit vector because it's only 1 unit long, but it's going in the same direction as my overall vector. Okay? Does that make sense? How you do a unit vector? You're basically just taking the unit vector, dividing it by how long it is, and then, yeah.
Yeah, I got it.
Okay, cool. Do you want to see another example of that?
I'm fine either way.
Think you're good? And okay, cool. So that's how you find a unit vector. Okay, let's do number. Let's do number 46 or 48 because it kind of uses this unit vector idea and takes it to the next level. Yay. All right, almost there. It doesn't really matter. Well, they're 45 through 50 are all the same. So we'll just go ahead and do 46. Okay, so it says in exercise 45 through 50, find the vector v with the given magnitude and the same direction as u. Okay, so we want our vector. So this is our direction, right? Our direction is at 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. We want our vector to have the same direction as u, but we only want it to have a magnitude of 3. So what do we need to do to figure that out? So your first instinct might be to just divide your vector u by 3 and just call it a day, right? Unfortunately, we can't quite do that. What we're going to need to do is we're going to need to find the unit vector for u. Okay, find the unit vector for u. And then we're going to need to multiply the unit vector by a magnitude of 3. Okay, so we're going to want to find the unit vector and then we're going to want to multiply by 3 in order to figure that out. So first thing we need to do is find the unit vector of this. So the unit vector is going to be, let's find the magnitude of u, which is basically going to be 4 minus 0 squared plus -4 minus 0 squared. Okay, so we're going to end up with square root of 4 squared plus 4 squared, which ends up being, if you do all that work, you get 4 square root of 2. Okay, so then my unit vector for u is going to be 4 divided by 4 square root of 2, -4 divided by 4 square root of 2. Okay, did you guys follow that? I just did what I did in the last thing to find the unit vector. Okay, I can simplify this. These 4's cancel out, and this actually will end up being, I multiply by the square root of 2. So this will be the square root of 2 over 2, this negative square root of 2 over 2. This is my unit vector for my vector u. Okay, but I want this unit vector to have a magnitude of 3. So what I would have to do, my last step to get a vector v that has a magnitude of 3, I have to multiply my unit vector by 3. So vector v is going to be 3 times the square root of 2 over 2, negative square root of 2 over 2, which equals 3 square root of 2 over 2, -3 square root of 2 over 2. So that will be my vector v that has a magnitude of 3 and in the same direction as u. Did I lose you there?
I mostly got it.
Okay. So basically, you're kind of combining, right? you want it to go the same direction as this unit vector. So you have to find out what one unit of this vector is, which is this first part. Oh, goodness. Okay. So if I find out a unit vector of this, which ends up being this, that's my unit vector. Okay. But I know I want it to be 3 long. So I take my unit vector and I multiply that unit vector by 3.
Okay, gotcha. Yeah.
Yeah. All right. I think we're almost there on this section. All right, let me show you these last few. Do you want to see another example of this, or you think that's all right? Try it
I
and
think
see.
that's all right. Yeah.
Yeah, try it and see. We can always come back to this kind of stuff too, because it's all new stuff, right? Okay, last little bit of this section is that the initial and terminal points of vectors are given. Write the vector as a linear combination of the standard unit vectors I and j. Okay, so I'm going to give you the visual of this first, and then we're going to do it algebraically. I'm going to do it 2 ways. Okay, so number 52. Okay, here we go. 1, 2, 3, 4. See, yeah, that'll work. 1, 2, 3, 4, 5, 6. Hold on. Let me start over. I really should have a coordinate plane that I just pull up on here. All right, let me give you the visual. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you have a vector. Its initial point is at 0, -2. Starts here, right? And it ends at 3, 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. So this is your vector, right? So this is the initial point and that's the terminal point. Write the vector as a linear combination of the standard unit vectors I and j. So basically what you're going to do is you're going to convert these initial points and these terminal points to I and j. So what I mean by that is, remember, I is like your x and j is like your y. So your initial point, if I would rewrite this in vector form for this, 0, -2 is just going to become -2j, right? And 3, 6 is going to become 3i plus 6j. Okay. And so then if I wanted to write a linear combination of the two of them, it's actually pretty easy. I'm just going to add them together. So what is -2j plus 3i plus 6j? It is 3i, right? Oh, sorry. I'm sorry, you're not going to do that. Erase, go back. Sorry. Erase that last 30 seconds. This is your end point. This is your beginning point. Initial point, right? To figure out what the difference is going to be, you're going to take the end and subtract the beginning, or the initial point. So your end point is 3i plus 6j, right? And your beginning point is -2j. And so you're going to get 3i minus negative, there you go, plus 8j. I apologize for that. I said that wrong. So to get the difference between the end point and the beginning point, you're going to subtract. Okay, so that means, since I kind of messed that one up, number 54, right? 54, the beginning point is going to be at negative 6I plus 4j, and the end point is going to be at just j. So I need to subtract j, the endpoint, minus negative 6I plus 4j, right? Which becomes j plus 6I minus 4j, or 6I minus 3j. Does that make sense? Sorta.
Yeah.
All right. So I think this one of those things you got to try, right? Try it and then see if it makes sense. Okay. I think all I'm going to do is show you one of the things that's going on in 6.4, because we're probably going to have to go ahead and review it on Monday. But let me go ahead and show you this just so you get to see it twice. So if you are, so the last section we talked about vectors, this section is also vectors, right? In the last section, we added vectors together, we subtracted them, and we multiplied by a scalar. But if you want to multiply two vectors together, just like you want to multiply two matrices together, you actually get to do something called the dot product, which is just like matrices. Okay, so what I mean by that is if you have one vector that is u1, u2, and the other one that is v1, v2, and you multiply them together, you are going to get a scalar number. So when you multiply two vectors together, you get a number. Okay, so in this case, if you had, let's just make up some numbers, 3, 5 times, I don't know, -1, 2. Okay, what you're going to do is you're going to multiply the first two values together. So you're going to get 3 times -1 plus 5 times 2. So -3 plus 10 equals 7. That's it. So it seems weird that when you multiply two vectors together, you get a number, but that's what happens. You multiply two numbers together, or two vectors together, you get a number. And that's called the dot product, which is just like a matrice, the scalar number. Okay, so then what we'll do on Monday is we'll do a lot of examples of this. But I just wanted to kind of give you a preview, heads up of that. So I'm guessing that we'll probably finish up next week, chapter 6, just to kind of give you guys a heads up of what's going on. We'll probably finish the 6.4 and 6.5 next week, and then kind of move on from there. So just to kind of give you a heads up, that's probably where we'll be at. But I think we'll just go ahead and wrap up for today and really dive into that vector multiplication on Monday. All right. Thank you, ladies, for coming today. I hope you stay warm.
Thanks.
All right. Talk to you later.
Yep. See you Monday.
See ya. Bye.